Good morning, everyone. Whoops. And welcome to React.js Conf. As the organizer of the conference, I'm so excited to be here. And before we get started, just a couple of announcements. So the first one, and unusual thing, is you need to drop off your badges before you exit the first day, and then we'll get them back to you the second day in the morning, and you can keep it. The second thing is, if you need to go to the restroom, they are near the registration. If you need to smoke or take a fresh air, you can exit by the door you came from. And if you need any help, look for people with flashy green T-shirts. They will be able to help you out. And so without further ado, I'm now inviting Tom to talk about React.
Thank you, Christopher. All right, so welcome, everyone. I'm probably as excited as he is, but he did put a lot of work into organizing this thing along with Christina, so let's get started. So thanks, Chris. So I've been here at Facebook for a while, and I've worked on a bunch of different things. You know, I used to build products. I built our search type ahead, and if you've ever mentioned anyone on Facebook, I built that input. But these days, I manage the React team. And you know, today, appropriately, I'm here to talk about React. The first thing I want to go over is where React actually came from. I feel like every week I hear a new podcast or a new interview with somebody talking about how React was actually started. So you know, there's dozens of stories floating around. I figured I'd give my perspective, my view of where React actually came from. And this is, feels like a good way to open up the first ever React.js Conf, right? So React was actually born in our ads org at Facebook. A while back, we were building these client-side applications, and they were pretty traditional. Client-side MVC, we used two-way data binding and templates. Same stuff that you're all familiar with. And just the way that these apps worked, views would listen to changes on models and then respond to those changes by updating themselves manually. And there were a bunch of apps built this way, and they were simple. They started out really simple. But as we added more and more features, they got more and more complicated. And as we added more and more people to the team, along with adding more features, we ended up slowing down a lot. As a company, we just started moving more slowly on these very big, very complicated code bases. So, over time, our apps just became a nightmare to work with. And what we realized is that on some changes to these apps, so some new data would flow in, what would happen is some small change somewhere deep in the tree would end up effectively having to re-render the entire app or figure out what needed to be changed and mutate all of these different views, right? We called these things cascading updates internally. These updates were really slow because not only do you have to do all the bookkeeping to figure out what needs to be mutated, then you need to go and actually have the views all update themselves. And there was a lot of wasted work here. So additionally, over time, engineers couldn't keep in their heads what would cause these cascading updates to happen, right? So the code was really, really unpredictable. We became less confident in the code that we were writing. And any time we changed anything, we were re-rendering most of our application anyway, right? The thing that we realized was that we already wrote code that described what our components looked like or what our applications looked like, given an initial set of data. So when the data changed, why can't we just re-execute that exact same code? There's some obvious problems with that, but conceptually, it's just so much simpler, right? So let's talk about some of the problems. First of all, you're going to get user experience glitches, right? If the user selects some text or has some state in the DOM, you're going to lose that state. Things are going to flicker. And additionally, it's going to be really inefficient to do this, right? There's going to be a huge waste of time and CPU on the client. But it wasn't that bad. And in fact, for the longest time on Facebook.com, the chat buddy list, this is actually how it was implemented. Anytime a buddy would come online or go offline, we would literally generate a new string of inner HTML and dump the thing into the DOM. And no one noticed. It's it works great. Conceptually, this was just so simple to understand. So the mental model, we knew we had the mental model right. We want to just describe what our views look like given any set of data. But we need to do something about how terrible the user experience was in certain cases and how bad it was for performance. So Jordan Walk, I don't know where he's at. Jordan? He's here somewhere. Attempted to build a prototype of something that would just make this process more efficient, and just a reasonable user experience. He didn't have a name for it yet, but that's actually when React was born. So people started playing around with this internally, and everyone had the same reaction. They were like, OK, A, I have no idea how this is going to be performant enough, but B, it's so fun to work with. Right? Everybody was like, this is so cool. I don't really care if it's too slow. Somebody will make it faster. So a few months later, while we were also building apps in our ads org, we started building our first feature on Facebook.com, the user-facing site that used React. And it was the like and comment experience. Right? We replaced a previously server-side rendered version of this application. It's basically an application with a version that was powered completely by React and Flux. And when we launched this thing, somewhat to our surprise, metrics were neutral to positive on this. So we're so excited, because now we have a code base that's significantly more maintainable and significantly more fun to work with. And React is on Facebook.com. And simultaneously, we were also building these ads products. So I took a screencast of me walking through our advertiser create flow, just so you can see how complicated some of these apps were. Because the like and comment experience, that was really simple. But let's look at this thing. So on the right-hand side, you have this audience definition. And then on the left is a form that allows you to just add different demographics, who can see this ad, basically. And we're computing in real time, as I add new cities, what your potential maximum estimated reach here is. So given these 3 cities and those radiuses, we're saying you could potentially reach 7.8 million people. And then you can change the age range. You can change the interests. You can change a bunch of stuff, right? If you'll notice when I scroll, after I add something here, we're only like 1/3 through this application, right? Imagine building this using a traditional MVC approach where you have to lay out your models and your views. How many models could we have counted already? Probably like, I don't know, several dozen, right? And we're only halfway through this form, not even. And this thing on the right, this view on the right, the problem with that view is that there are so many different models that feed into that view's output. Writing the code to manage this thing, it was insane, OK? In a traditional MVC approach, this application for us was just so hard to build. And then the worst part about it was that this thing just broke all the time because nobody knew how to change it. Everybody was so scared to make changes to it. So anyway, I'll talk more about this in a minute. And also, Jason Bonta later today is going to give a presentation on some of our ads interfaces and how we make them fast. But let's continue with the where React came from timeline. Around the same time that we were doing all this work, Instagram joined Facebook. And they had a bunch of projects they wanted to work on. One of the first ones they wanted to do was Instagram.com. So they took a look at Facebook's stack, and they're like, man, this React thing looks really cool. We want to use that. The problem was, at the time, React was really, really tightly coupled to our Facebook-specific software stack, right? So they wanted to decouple it so that they could use it on Instagram. And Pete Hunt convinced us that this was worthwhile. Pete, where are you at? Right. So Pete actually did most of the work to do this. Thank you, Pete. And he did most of the work to effectively make React open sourceable. So at JSConf in 2013, it was 2013, we decided to do just that. And first impressions were pretty skeptical. Right? Everyone was paying attention, I think, until we got to this slide. That's the actual slide that Jordan pulled up. I know, Chris, you're laughing. You remember this. Everybody kind of tuned out. They just shut off. They're like, I don't know what that is. I've never seen that. Yeah, that's right. They took to Twitter. What they told us was that we'd taken a huge step backwards in terms of the maintainability of our code, simply because we were embedding our markup, or our HTML, inside of our JavaScript. This was crazy. You can't do that. But internally, this wasn't controversial at all. We had a ton of experience with this syntax because we'd been using it for years already, at least 4 years at the time. We introduced XHP into our PHP stack, which was really simple. We actually open sourced this in 2010 as well. But it was super simple. Here's what it did. It took code that looked like this, little XML fragments inside of your inside of your PHP code, and it would desugar those declarations into basically function calls. Super simple, right? But there were a ton of benefits to this approach. For one, and probably what we thought was the most important benefit at the time, was that it made cross-site scripting attacks a thing of the past. right? We now know where each bit of content is going to be rendered. We know if it's going to be user-facing, so we can escape it for you automatically. Engineers no longer need to type HTML special characters, right? At the time, we're like, oh my gosh, this is amazing. This is the best thing ever. But that wasn't the most important piece. The most important piece about XHP was that it allowed us to create composite components. These composite components, when I would create an FB Joule, that wouldn't just send down the markup necessary to render a Joule. The Joule is the little icons at the top of Facebook.com that you click for your notifications, by the way. It wouldn't just send down the markup. It would send down all of the style and presentation information that you needed too, as well as all of the JavaScript that made the thing actually do something. But we went one step further than that. We actually made it so you could create components that took in very simple parameters, like a viewer, and what type of data you want. And they would do all the necessary data fetching to make it so that you have a fully functional dynamic component with all of the data that it needs just by calling that API just like that. And then behind the scenes, under the hood, there was all sorts of parallelizing of data fetching across components. And there was caching layers and CDNs. But as a client of this component, I didn't have to think about any of that. I didn't need to worry about how it worked. It worked. The implementation didn't matter to me. This is a component. This, we feel, is the proper separation of concerns for our applications. We introduced this little syntax into React because it was more composable and more approachable for people who'd seen XHP before. If you've ever tried to declare JSON views using JSON, you have all these curly braces and parentheses. Well, with XML tags, you actually see the closing tag on the closing line. That was the reason we used the syntax. But still, and this is my favorite tweet of all time, Facebook was kind of accused of rethinking established best practices simply because we were storing our markup in our JavaScript. This tweet was a little bit sarcastic at the time. I love Ben. We've had tons of conversations about it. But we appreciated this tweet. We're like, man, finally somebody's acknowledging. Kind of or rethinking the way that everybody's doing things. So perhaps, not coincidentally, Pete gave a talk at JSConf EU, and he called the talk Rethinking Best Practices. And this was great, right? Pete's talk, if you haven't seen it, you've all seen it. I'm sure you've all seen it, right? This talk went over a lot of React's principles, its fundamental principles that made it exciting. And it went over a lot of the things that made it powerful. But if I was to ask everyone in this room individually what it is that makes React powerful, I think I'd probably get a bunch of different answers. The most common, the most obvious one is the virtual DOM, right? This is React's claim to fame. This is the thing that kind of set it apart initially. And now we have standalone virtual DOM implementations, which is awesome. We have the virtual DOM being implemented into other JavaScript frameworks. This is great. But another feature that a lot of people called out as being React's most powerful feature was server rendering. And just last night, Bonnie from Code Academy, there she is, thank you, Bonnie, told me that Code Academy actually chose to use React because server-side rendering worked out of the box so easily. But for people who aren't familiar with React, they'd probably call out the descriptive warning messages as the most powerful feature. When you use this framework for the first time and you do something wrong, it tells you exactly what you did wrong and how to fix it. Here's the line in your code you need to fix. There's also the custom event system and a bunch of other features. But the thing that makes all of these features and more possible is the fact that React replaces an imperative mutative API with a declarative API that favors immutability. And internally, I don't think we understood this at first. When we started working with React, I know I certainly didn't understand this. It wasn't until we built a bunch of products on React that we had to change over time and extend and add features to that we realized that the operative word here was actually declarative. When we create our applications using declarative code and when we structure our views declaratively, your code is significantly more predictable. The fact that you can open up any JavaScript file with a React component in it and understand all of the possible states of that component and exactly how it's going to behave just by looking at that file is incredibly powerful. And when our code is declarative and therefore predictable, we can make changes to it more easily with confidence. Engineers don't need to spend a ton of time trying to understand the entire system before they can make a change to one small piece of it. We live this. We're experiencing this every day at Facebook. We have engineers that join Facebook, have never worked with React before. They join a team building a React application, and on their first day, they can make changes to that code base with confidence, having never worked with React before. This is insane. I've never seen this before. But the best part, I think, about being able to make changes with confidence is that when you can change your code more confidently, it ends up being a lot more reliable. So I mentioned that our ads create flow used to break all the time. It used to break multiple times a week. But when we converted it to React and Flux, it never goes down anymore. And we didn't slow down. We didn't stop adding features. In fact, we sped up. We've added more features in less time with more engineers than we ever could before, which has had a meaningful impact on the success of our business. So I think that React's real power lies in how it makes you structure your code in terms of React components. The only reason anything like the virtual DOM or conceptually re-rendering on every single update is even possible is because we've used React components. Rather than trying to force things into models, views, and controllers, we separate all of our concerns into components. Components are the fundamental building blocks of our application. I was talking to Jay Longsters last night. Where is he? Jay Longster. Yo. And we were talking about what it is about React components, though, that makes them different. Because a lot of frameworks have figured this out. You have directives, you have web components, you have a lot of other frameworks that have figured out that components are the right separation of concerns. But what makes React different? Well, from my experience, the difference is that in all those other situations, you have to create your component using imperative mutative code. But in React, you get to describe your component declaratively. And I've proposed that declarative code is a lot easier to maintain and easier to extend. And additionally, again, from my own experience, it's just a lot more fun. So we think we've really hit a home run with React. We're using it everywhere internally. Everybody loves using this stuff. But the problem is, we're only using it for web stuff. We've also got these iOS and Android apps with hundreds of millions of users. And we've tried in the past to just build web apps that we could wrap in thin native wrappers. But it doesn't work. The reason that you can't just build a web app and expect it to behave like a native app is because building for the native platform yields a vastly different user experience than building for the browser environment. Has anyone here used Facebook's Paper app? Raise your hand. Yeah. So this app feels amazing. It's probably the best feeling iOS app that there is. And one of the reasons, or there's many reasons that it feels so amazing, but people have tried to clone this on the web, and no one gets even close. They might clone one feature or one gesture, and it might be a huge code base, but no one gets even close to something that feels as good and is as complete as Paper. Why is that? Why can't we build something like Paper using web technologies? Well, the first reason is because in native, we have the ability to parallelize work onto multiple threads. I'm going to let this video play in the background, but I'll just keep talking about some of the things that are going on. With Paper, we created a framework called Async Display Kit, which allows you to get rendering off of the main thread, which enables you to do some of these super smooth animations. We have web workers in the browser. Some people call out web workers. You can parallelize work using web workers. But web workers are a really crippled API. You cannot do image decoding in a web worker unless you like cross-compile and script in. This is crazy. Pete Hunt tried this. Don't do this. You can't do text measurement. You can't do layout, right? So we just don't have the power, truly, of multiple threads. We also don't have sophisticated gesture handling. This is another thing that sets native apart. On web, we have all of the raw materials. We have the touch events coming into the system, but we don't have two things. One, the proper tooling, and two, the developer discipline around building a gesture system that is advanced and as sophisticated as the native gesture systems. Another thing we have on native is access to platform-specific capabilities and components. Native widgets are a black box. We don't have access to the source code. We can't see what the parameters are. We don't know what the numbers are, the different things that make them feel like they feel. And any time somebody tries to re-implement a native widget using HTML, CSS, and JavaScript, it always feels like shit. You can get close. You can kind of make something that, yeah, it's like, oh, it's almost indistinguishable. It's not even close. And there's another reason here. In native, we have access to things that you actually just don't have access to. Let's take a Maps widget, for example. There is no way to access Apple's map data outside of MapKit on iOS, for example. So you can't create a map implementation that looks and feels like the native component. On native, we might want to re-implement widgets sometimes, but on web, we're forced to. So as much as it pains me to say it, and I hate to say it, the native environment is far more flexible and far more powerful than the browser environment, at least today. But all that power and flexibility comes with a cost. It's not free. The native environment is, in general, far more hostile to developers and to organizations. When we started building a native-specific iOS app and a native-specific Android app, we had to spin up 2 separate sets of tooling, 2 separate sets of abstractions, and all of this specific platform code and infrastructure and teams that it wasn't portable. We couldn't reuse these concepts. And not only that, now we have to think about things like memory management and thread concurrency and laying out subviews. And also, we have to think about things like provisioning profiles for our devices. You can't just load up a browser window anymore. You also can't just push your entire application by saying git push. Now you have to think about the deployment process, right? So it adds an unnecessary, well, it adds a necessary overhead to developing applications. And there's another reason it's hard to build native apps. In native, just like with the DOM, you have to use mutative imperative APIs. And we've seen this before. Okay? Whenever we try to build a sophisticated application using those APIs, over time as it gets more complicated and we add more people to the team, this breaks down. But let's get back to React. From the beginning, React has been designed to be able to replace any view system. It can wrap any imperative view system. It doesn't need to just wrap the DOM. What if we take the exact same React JavaScript we've been running on web, and we could use it to power truly native applications? Well, that's exactly what we've been working on. We're calling it React Native. Man, I feel like Steve Jobs. We're calling it React Native, and we're building it simultaneously for iOS and Android. Now, I'm primarily going to focus on React iOS today, but again, we're building it for both platforms. I have a demo. If I click next, it'll just show you a video, or I can just use the phone and do it live. What do you guys want? All right, I'll do it live. I know, right? OK. So the first thing I'm going to show you here is a very simple movies app. So this app, it literally just lists out movies. And you can tap any of the movies and see a detailed description of it. And you can go back. And this is pretty simple. I can search for movies. Let's see, I'm excited about Furious 7. Perfect. Furious 6. OK. Right? And the things you can't see is when I tap the native status bar, I tap the status bar at the top, this thing scrolls to the top. It's a native behavior. The other thing you might not notice is as I'm swiping, this is the native navigator. This is actually iOS. These are native components. The next app I'm going to show real quick is actually in the App Store, so you can all download it and play with it. This is Facebook's Groups app. Now, this app is actually a combination of native code and React native code. My challenge to you is figure out which parts are which. So I'll just jump into the React.js Conf group. We have a photo here. I'm just going to open that. Can zoom, flip. I really do feel like Steve Jobs right now. This is crazy. I'm going to like a post. I'm going to go into another group here so I can do some more fun stuff. We have this multi-photo post where you can swipe between photos, flick them away. View previous comments here. Boom. I'm going to focus this text box, and what happens, this is pretty cool. When I go to the top of the post, I no longer am in the feed anymore. I'm in a permalink view. I can post, hey, right? So that actually works. This is pretty cool, too. When I like a post that didn't have a like before, that animation when the one like jumps in. I really like that. OK, cool. So back to the presentation. All right, what was that? What was that? The first thing to note, and the most important thing to note, is that everything you saw on the screen was completely native. Okay? We can't use the web to build an experience like that. We've tried many times. So there was no HTML, there was no browser, there were no web views, but it was completely controlled by JavaScript. Now, there are other frameworks that exist today that script native APIs in JavaScript. There's a problem, though. The problem with wrapping native is you still have to use these imperative mutative APIs. Okay? The only thing that they change is the code that we're writing in. So if you just introduce JavaScript naively, this could actually end up being a lot worse. If we're naive here, we could get into a situation where we're dropping frames in the UI because we're waiting on JavaScript to do some work. For example, JavaScript could be running garbage collection, and our main thread is dropping frames. So if we're going to introduce a JavaScript layer, we have to be smart about it. The layer needs to be asynchronous. That way, we can do anything we want in the JavaScript thread, and we won't affect the actual rendering, the UI. We won't block. And additionally, for perf, we should be able to batch up all the instructions we want to execute on native, and then execute them whenever we can. So we'll yield to the main thread whenever we need to. We know that React diffs subsequent versions of the virtual DOM, right? So it's perfect for this. We create these diffs, we create these sets of instructions, we throw them into a task queue, and then we execute them on native. It turns all those imperative API calls, when we're running this on the web, into DOM, set attribute calls and things like that. But again, there's no reason we have to render to the DOM, right? So we had this set of primitives on the web of divs and spans and images. But on the native platform, we have a different set of primitives. They're UI views and text and images on iOS. On Android, they're Android views. So we take this task queue, we interpret all of these things that came in, all the changes that need to be made. It used to be set attribute ID this, or set color that. And now we turn them into imperative native calls. And this is actually where a lot of the work for React Native went. We have these thin wrappers that basically convert those declarative properties into imperative code. But probably the coolest thing about this is that we can take advantage of multi-core architectures a lot better. By putting the JavaScript in a background thread, we can make it so that all of your application logic, including your rendering, is always rendering, it's always executing off of the main thread. Now, this is what makes Paper using async display kit so powerful. But the difference is that with Paper, the only thing that's happening off the main thread with that framework is rendering. So, and then in native, you have to restructure your app a bunch of different ways. But with this architecture, we're saying all of your application code, all of your JavaScript is running off the main thread by default. So just like when we introduced React a couple years ago, this is working for us. It's in the App Store. Download Facebook's group app if you want. We have more coming soon. Some people think that since we have this tool at our disposal now, we're just going to revert back to having a single code base and build all of our apps using that. But I want to make it very clear that that's not our goal. We don't want to have a single code base that powers all of our applications, all of our platforms. We're not chasing the write once, run anywhere pipe dream, right? These platforms have different looks and feels, different behaviors, okay? And when you're building an Android application, you're not thinking about iOS principles. You're thinking about Android principles. So instead, what we want to do is chase the learn once, write anywhere paradigm. Thank you, Nick Schrock, for coming up with this. We want to be able to develop a consistent set of tools and technologies that let us build applications using the same set of principles across whatever platform we want. What this means is that a set of engineers can build an iOS app, and they can turn around the next day and build the exact same app for Android just by virtue of knowing React. They don't need special IDEs or special environments. They can just build using React. So tomorrow morning, Christopher Chateau is going to go into an actual coding demo. He's going to change some stuff live, and you can see it. I don't have time to get into code now. I actually have only 13 seconds left, but I'm going to take an extra 30 seconds to talk about where the code is. So we're going to open source this soon, but everybody at React.js Conf is going to have access to the GitHub repo tomorrow. It's still pretty bare bones, but we're adding more to it every day, so there's going to be features dropping and landing every single day. So I'm going to wrap up with just a very, very quick story. So before we open source React, there were some people, Sebastian, this is pretty funny. He's like, Jordan, you know that people are going to hate this, right? And Jordan was like, man, what the heck? But what I was telling the team was, look, this is really exciting. This release is very exciting for all of us. But the thing that I'm more excited about is what happens next. Because we all know what happened next, right? We fundamentally changed the way that a lot of people think about JavaScript, application structure. And simply because React was released, a lot of other JavaScript frameworks have taken notice and have been influenced. And this is just an approximation. I'm just estimating, but the number of frameworks that have been influenced by what React is doing is somewhere around all of them. Right? And not only that, we're changing the way that people think about JavaScript. It's like a couple years ago, everything was about object.observe, but now we're seeing the community say, hey, immutability, that's actually pretty interesting. Maybe we should focus on that. So I'm excited that we just continue rethinking best practices. I want to thank this community for making it possible for us to keep investing in this and keep working on it. That's all I got. Thanks.